Awesome. Thank you, Glenn. Technical difficulties, but we work in technology, so this happens. Give it another minute. Let some of the final stragglers kind of come on in here, and we'll get started. Glad to be back. We're back from Valencia, Spain, so it's kind of exciting to. It's my first show in a while. Obviously, first show being back in the States. All right. Well, I guess we can get started. Welcome to the Global Online Meetup of May 2022, introducing NeuVector 5.0. NeuVector went live last week while we were at KubeCon in Europe with the 5.0 release, and we're here, and we'll talk about that and what it means with this huge, monumentous release for NeuVector. Next slide. Our agenda today is a brief introduction, an overview of NeuVector 5.0, a quick demo, and a Q&A session, and we'll wrap up with some key takeaways to get started with NeuVector. We are using Crowdcast. This is a platform that you are all logged into and you're using currently. In the bottom bar below, you'll see a chat box. If you feel comfortable, say hi, ask questions in there. You have an ask questions button. Please ask questions, but you can upvote and downvote questions. So if there's a question that's you want to hear the answer to, upvote it. If we don't get to all of your questions today in the time allotted, we will answer those questions in the community. I usually go back and answer them with our guests. So don't worry if you don't get it answered. And if I had a penny for every time someone asks me if this event is being recorded, it is being recorded. You can come back here to Crowdcast and watch it, but this afternoon I will have this posted on our YouTube channel and you can go out and watch it there as well. Next slide. My name is Robert Sirchia. I am a senior technical evangelist here at SUSE, and my esteemed guest is the head of product security at SUSE, Glen Kosaka. Glen, welcome. Thank you for showing up.
Thank you, Robert. Glad to be here.
Thank you. All right, next slide. This is a meetup. This is not a webinar. So if you have questions, ask them. We will answer them as soon as possible. We don't necessarily have to wait for the end. Sometimes it's important to kind of pause, have the question asked, and then we'll answer as soon as possible. But we'll try to get back to it. Next slide. Meetup rules, obviously be flexible, ask questions. There's no bad questions. So if you have something out there, please ask it. Demos are demos, right? If they break, be patient, we'll get back to it. I get excited when a demo breaks because it shows you that we're really pushing the envelope of what we're doing here and any of the products and projects that we have. Next slide. And I talked about this being recorded. And if you want some more questions, you can join us in our Rancher Slack. There is a dedicated Slack channel at the end of this. You will see, we'll have the URL to join the dedicated Slack channel for Rancher and NeuVector. So you can go right there, ask your questions around NeuVector. Next slide. And obviously we have the community.suse.com. You can ask your questions there. You can sign up at community.suse.com. or click the link, the little green button below, and that will take you right there where you can sign up for the community. And without further ado, I'm going to turn this over to our esteemed guest, Glen. Floor is yours, sir.
All right, thank you. It's great to be here during this exciting time. As Robert mentioned, we launched NeuVector 5 last week at KubeCon. It's the first open source version of the NeuVector container security platform. So today I'm going to talk about not just what's new in NeuVector, because I know a lot of you are probably not familiar with NeuVector in general or container security in general. So I'll cover that first, and then I'll try to highlight specific things that are new in this 5.0 version. So I'm going to take a step back and really talk about the security environment for containers and Kubernetes clusters. As we know, a lot of these are going into production. And if you have any sensitive data, or if you have business critical logic running into your container environment, that's when it's going to be critical to protect that environment from hackers, from zero-day exploits, vulnerability exploits, any type of intrusion into your systems. The problem with container environments is that your traditional security tools don't work in those environments, either for a couple reasons. One is they just can't have that visibility. So for example, Kubernetes abstracts through a CNI, the networking layer above your traditional network layer. And that really disables or makes blind any type of tools that you had previously used for VMs or for data centers. So how do you get that visibility, that deep network packet level visibility, and implement all of those network controls that you had and that were so critical in a more traditional environment? And it's not just that. How do you monitor the process and file activity in containers and workloads as they're coming up and spinning down and being migrated from node to node or drained? Your traditional tools are not going to be able to keep up. So visibility and protection is the first area that is an issue. And the second one is velocity. Most of you are building clusters and container environments so that you can have maybe even a fully automated CI/CD pipeline where you're releasing applications or you're updating applications tens or hundreds or thousands of times a week or a month. And security tools cannot slow down that pipeline. You can't have manual steps in that pipeline. You can't have someone being required to contact the firewall team to request an open port or connection external. And that's going to take your typical 1 or 2 days to evaluate, test, and answer your request. That just doesn't work in a modern cloud environment. So being able to build security into the pipeline is a critical issue and aspect of what you are going to be able to look for in platforms like NeuVector. And just like in a traditional data center or VM environment, the best defense is defense in depth. And that's where you have multiple layers of security so that at any point in what's called the kill chain, whether it's the ingress, whether it's expansion, whether it's connection to command and control, exploit, download exploitable packages, or the actual stealing of data, at any point in those multitude of security events, you have a chance of detecting that if you have a layered security approach and preventing those things from happening. So today, the hot two hot terms today are supply chain security. How do we protect bad stuff from getting into our pipeline or a supply chain and getting into that production environment? So for that, we're going to employ vulnerability scanning for CVEs in images and in running containers, compliance scanning, CIS benchmarks, or other audits to make sure inadvertently some configuration hasn't been changed that leaves an attack surface open. Admission control is your final gate between your pipeline and your production and your runtime environment. So supply chain security is one of those hot terms. The other one I would point out is the bottom right is the zero trust controls. So I'll talk about zero trust controls and why the security industry is moving from threat-based controls to zero trust controls. But those are all really there to protect your containers and their environment during the runtime in production. So if we contrast threat-based controls and zero trust controls, I would put threat-based controls more as your traditional or legacy security controls. They're not unnecessary or irrelevant in a container environment. They still provide valuable functions and protections, especially as we talked about a layered security strategy. And so in this category, we're going to look for previously discovered and disclosed vulnerabilities in the form of CVEs and try to get those out. We're also going to look for patterns that could represent sensitive data like credit cards or social security numbers. And so that's in data loss prevention. Traditional network attacks such as SQL injection, cross-site scripting, other things that a web application firewall could detect, cross-site request forgery, all of those are kind of signature-based attacks, and we'll still want to look for those. And then finally, admission controls. Actually, I would put admission controls, they can either be threat-based or they can be zero trust-based. Just a quick definition of zero trust is that instead of trying to define the bad stuff that we're trying to prevent, we are going to define the trusted behavior or allowed users. And once everything is locked down, everything else is untrusted. So if I go back to admission controls, I could put in place an admission control that says, block these specific CVEs from entering my pipeline. That's more of a threat-based control. But if I say only allow deployments from this trusted production registry into these namespaces with these labels, then I'm moving more into admission controls that are implementing zero trust controls. So that's a good example of the difference between the two. Now, under zero trust controls for the runtime environment, we have a number of capabilities. Automated learning is important just to help you to build a profile of your application behavior. What network connections is it making as I test it out? What process and file activity is being exhibited? And then we can help build those zero trust rules. So if we look at network process and file access, those are the three key things we can declare as zero trust controls. We can say this deployment of an application or microservice and its pods that are deployed can only make these network connections, these pod-to-pod connections within the cluster, as well as these ingress and egress connections are allowed. We can further segment that by the allowed protocols that can be used in those connections. Now, process and file access is more looking into the behavior within the container itself. So what processes are going to be allowed, what file activity is going to be allowed. And you'll see later, while you can declare all those processes and file accesses, we have a new feature in 5.0, which will just by default automatically lock down your hardened containers to only allow the original processes and file activity that were defined in the container image. All of those capabilities combined with custom resource definitions enable you to implement security as code. And this is critical to keep up with the velocity that I talked about. You have the ability to declare through a CRD YAML file the allowed behavior of an application or microservice before it's even deployed. And then with kubectl apply, you can simply push those rules into the production environment. Once your app is deployed, it will have all of the protections required to prevent zero-day attacks. And if that app needs to be updated, it's the same way you manage your code. You check out that security YAML, you update it to allow the new behavior in your container, you run it through your test cycles, QA cycles. Once it's approved, you check it back into your code repo, and then you push it into the production environment. So that is a critical concept to be able to move to zero trust controls as well. So the NeuVector solution, which is now open source and available from Docker Hub or the Rancher repo, brings great capabilities that you will not find in any other container security solution. It really focuses on these zero trust protections for network, process, and file, and specifically the deep network visibility on a packet by packet basis that is provided. So you have the ability to inspect all of the network traffic, know what protocols are being used, know what's in the URL, what's in the header, and to define protections and put in protections in place to be able to block any unauthorized activity. This supports both air-gapped environments, public cloud environments where you do have a connection to the internet, and it's easy to deploy. The NeuVector solution is a container, a set of containers itself, a control plane. It's very similar to the Kubernetes architecture. There's a control plane, there's like a kubelet, there's an enforcer plane that runs as a daemon set on every node. A single container provides all of those protections. And because it's Kubernetes native, we deploy seamlessly and in an integrated way through Rancher, but NeuVector is also supported on any Kubernetes orchestrator, including all the public cloud ones, GKE, EKS, AKS, all of those as well.
So is it fair to say that it has to be a CNCF certified distribution of Kubernetes that's supported?
It does not need to be CNCF certified.
Oh.
You know, it's any Kubernetes distribution that, well, there are some dependencies on container runtime, but NeuVector supports all the popular container runtimes, Cryo, Containerd, even AWS Bottle Rocket, and your old trusty Docker runtime. So you don't need Kubernetes to run NeuVector. If you just have a Docker set of Docker hosts, you can run NeuVector on those to protect those as well.
Oh, wow. That's cool.
So I have already talked about zero trust for containers. It starts with automated behavior-based learning. This is where NeuVector can make your life easier. And in a test or staging environment, run your test scripts and NeuVector will come up with all the rules needed. Zero trust segmentation, the ability to either just monitor the behavior and then alert you if anything is detected, or in a protect mode, not just alerting, but can actually block connections on a connection by connection and application by application basis, or processes that are unauthorized or file activity as well. And I talked about security policy as code. I talked about building it into your pipeline, but it's also a great way to, once you've locked everything down in your staging environment, it's a great way using CRDs to propagate that to multiple production clusters. So policy promotion or automation of deploying a Kubernetes cluster, deploying NeuVector, everything can be automated. We have some customers that bring up Kubernetes clusters on demand, deploying NeuVector through whether it's Helm or operators, use a config map to configure it, and use the REST API and kubectl to push these CRD policies into there. So it's ready for the applications to be deployed. It's all going to be secured coming up. So as we mentioned, very excited about this open source release. You can, I'll show later how to participate in it and provide input from the community. But of course, you can subscribe to SUSE for a supported version of NeuVector. Now, NeuVector fits into the SUSE security stack. Really, our goal is to enable you to deploy a complete cloud-native stack that has a number of default configurations so you can feel comfortable that you have some basic security controls in place. And then, of course, you can customize from there. But by being able to integrate this together, we can make this a seamless experience, a little bit more push button. We recognize that many of you are not security architects or firewall experts out there, so we can make your lives easier with that. Okay, so let's talk about 5.0, what's new in 5.0. And before I talk about that, there's three major use cases that we see for NeuVector. Compliance being one of them. How do you achieve PCI compliance in a container environment where everything's new? None of those traditional tools work, but all of those protections are required by compliance. So NeuVector can be used to help you achieve compliance. We talked about security automation, building security into every part of the pipeline and automating it. And then finally, defense in depth, using zero trust controls together with traditional threat-based controls to protect against zero-day attacks, vulnerability exploits, malware, all of the things that you're familiar with. So with 5.0, we are adding a seamless Rancher experience. I'll show you that. You can deploy NeuVector easily through Rancher charts and then easily log in single sign-on to manage NeuVector. Of course, we have the ability to scan all of the SUSE Linux flavors. So just SLE, the enterprise version, BCI, the base container image, micro, any version of SLE that you're using, we can monitor that for CVEs as well. We have a new feature, which I alluded to. It's called Zero Drift Process and File Protection. And in that, we're going to, and by the way, this is the new default in 5.0. For every deployment that you make, we're going to scan the image that we get from the running container. It doesn't require a registry image scan. We're going to know from the container image what processes should be allowed in this container and what file activity should be allowed. And this works as an automated protection that you don't have to lift a finger, and you're going to get process and file protection in every deployment. Now in order for this to work, we would recommend that you harden your containers, because then you're going to remove all unnecessary packages and libraries and services from those hardened images. You have a slim profile, and it's easy for NeuVector to know what should be allowed and what should not be allowed at that point. And anything that's not deriving from the original base image, processes, or file will be deemed untrusted. And in a monitor mode, we'll alert. In a protect mode, we'll block that activity. We've added a web application firewall capability, which is deep packet inspection, being able to look into the header URL or packet body of every connection and look for OWASP top 10 type of attacks, cross-site scripting, SQL injection. We even added, right after Log4j came out, we added a WAF rule to be able to detect a Log4j attempted exploit. Now, this capability can also be used for API security if you have connections to API services. A very simple example of that would be to only allow HTTPS GET requests and to deny any type of POST requests. But of course, much more sophisticated security controls can be put in place. NeuVector supports very extensive admission control rules, DOP, and WAF rules. And so in order to support security as code, we've added the support for being able to declare those through a CRD. And the way all CRDs work in NeuVector is if you declare, whether it's a network control, whether it's a mission control rule or WAF rule, if you declare that through the CRD process, then those will not be editable by a local admin that logs into the cluster. or through the REST API. They must be updated through the CRD. And that way, that YAML file can represent the definitive state of the rules in NeuVector and not get changed and not represent that or kind of get out of sync over time. Automated protection modes are really capabilities to enable, if you just have a simple deployment, start it in Discover mode, NeuVector will learn the behavior, turn zero drift on, and then NeuVector will automatically move from a Discover learning mode into a monitor mode after a certain amount of time. And if there's no violations or alerts within another configurable amount of time, then NeuVector is going to move your protection state into the protect mode from monitor to protect. So that's from alerting to blocking. And so that can just make your life easier, not having to keep track of different deployments and have, manually moving them between different states.
Real quick, Glenn, are those different modes, is that manual, or does NeuVector actually know when to move on with that? And can you override it if it does?
Right. So that's this automated protection mode.
Okay.
In the past, those were, I'd say, mostly manual, where you would decide when to move from Discover to Monitor to Protect. Mm-hmm. Now, what you could do, if you were using CRDs, you could define that protection mode through the CRD. Like as part of the deployment of the network process and file rules for an application, you could define what protection mode that application is in, whether it's Discover, Monitor, or Protect. So that's one way to automate it. Another way is there's a setting in NeuVector that's called the New Services Protection Mode. You can force any new service, application that's being deployed that NeuVector is not familiar with to be in a monitor or protect mode. And that way, if anything's being deployed and NeuVector has not seen it up to now, we can make sure it's in monitor protect mode. If you've got the CRD that's already pumped in rules for it, it will be allowed to operate. If you don't have any rules for it, it's going to start firing off alerts or blocking connections. And then the last automation is the one I just talked about, where you can define a time frame where NeuVector will automatically migrate your protection modes. So many different choices there.
Awesome. Thank you.
So here's a summary of what I just talked about in the, moving from closed source, which required a license, to open source, with the integration of Rancher. One thing I should mention, we announced last week that we have applied or submitted this project under the name Open Zero Trust to the CNCF as a sandbox project. So the TOC will be able to evaluate that probably in a couple months and let us know. But that's exciting as well, that we really want there to be a community developed around improving and enhancing these type of zero trust controls. So in addition to Rancher and SUSE integrations, we also added, Microsoft has their own container format, and RKE2 as well as K3S. In the future, we're looking to other SUSE products, so Kuborden integration, Longhorn integration, other types of integrations to make life easier. And then I've talked about all the new runtime container security capabilities that are in 5.0. Okay, so let's switch over to the demo. So I'm going to start with the Rancher Manager. And if you're familiar with Rancher, then you're familiar with this interface. Now, just for simple demo purposes, I did deploy NeuVector on my local Rancher cluster, but I will say that most of the time you're going to deploy NeuVector downstream on a downstream cluster. However, I do recommend that you consider deploying NeuVector on your local Rancher Manager cluster as well, because for that cluster, it is a Kubernetes cluster, and NeuVector can monitor and protect it. So scan it for vulnerabilities, run CIS benchmarks on that local cluster, and look for potential attacks. So there's a value to running NeuVector on that. But I've got everything running on my local cluster, which I know typically in your environment, you would run things on a downstream cluster. So if I go to that cluster, now the first thing I will let you know is that when you search for NeuVector in Rancher charts, you'll find the NeuVector Helm chart. And there's a number of configurations that you can make to the values file through this deployment. The ones that I would point out are containerd. There's a setting, RKE2 uses containerd, whereas RKE uses Docker. So there's a setting in here to change the target runtime to containerd or other runtimes as you're using them. K3s has a specific, a different path than your typical Rancher RKE2 deployment. So there's a special setting for K3s. So make sure that and other configurations are set appropriately. This will deploy into a fixed Rancher created namespace, Cattle's NeuVector system. And that's what's used to enable the single sign-on. So for this deployment, you cannot change that namespace. But go, look through that, make the appropriate changes, deploy, and once you deploy, you will see NeuVector deployed. And where are my workloads? So the enforcer is deployed as a daemon set. And the control plane, controller pod, you can see 3 for HA. Manager is a stateless manager, only 1 needed. And then scanners. The scanners do the vulnerability scanning and can scale up as a replica set. If you need to scan a registry with 10,000 images in it, you may want to have 10 scanners so it can do it faster. And once you deploy NeuVector, you will see in this menu here, this button, which when clicked on, you can go straight to manage NeuVector, single sign-on through Rancher. So this is, as I mentioned, the cluster that we were taking a look at. However, NeuVector does support multi-cluster security management. And so you could see here, you can federate a number of clusters together and manage them through NeuVector. And you'll be able to do things like monitor multiple clusters from a security perspective and create admission control rules, network rules, that then get propagated down to all clusters that are federated. So coming into your local cluster, you will see a dashboard, which is a summary of the security risks that we're detecting, a number of different metrics on security events, and even network traffic and protocol usage in your cluster. Network activity is a great way to really see what's going on in your cluster. All the network connections will be shown here. So as you run test traffic through your applications, you'll see, for example, blue lines, which represent allowed connections where there's a zero trust rule in place, like this Redis connection from Node.js is rule number 7 that allows that using the Redis application protocol. But you will also see if there are any violations. In this case, this Node.js pod tried to connect externally, and there was no rule to allow an external connection just to the internet in general. So in this one, we're just for demo showing it's trying to connect to Amazon. However, another critical aspect of declarative security policy is if your pods are going to make external connections that are allowed, to actually define those and declare those. So in this case, let's see, I have something here, which is a connection to a Google API service, and it's in blue. So you could see here, there's an SSL connection allowed from my Node.js pods, and rule number 5 has been declared to allow connections just to address equals api.google.com. So you have the ability to declare allowed external connections. And in fact, when Log4j came out, one of the things that was mentioned was strict egress controls are a best practice for preventing Log4j exploits and many other type of exploits, because it will try to make an external connection to a LDAP server and then to a command and control server. So, don't allow external connections to the internet in general. But if you do not have any connections allowed externally declared in NeuVector, no external connections will be allowed. So just explicitly define only those that are required. You can also look at a number of details about each of the pods, how they're deployed, vulnerabilities in them, how many scale the replica, 3 of those. You can see the network rules and any other rules here. So going down to assets, this is where you're going to look at, this is a Kubernetes version, 123, no vulnerabilities, good stuff. This happens to be running Rancher on GKE, so you can see it's using the standard COS OS from GKE, but you can see there's a few vulnerabilities on those hosts. You can see the Kubernetes CIS benchmarks running on those as well. And you can also see for each container vulnerabilities during runtime that are being detected, as well as Docker and CIS benchmarks that are run on containers themselves. And registries is where you're going to define the registry scanning capability. Now, I didn't highlight too much, but you can build NeuVector into your build pipeline. So whatever build tool you're using, whether it's GitLab or Jenkins, CircleCI, Azure DevOps, you can use our plugin or extension to trigger a scanner to spin up, scan that image, and then reject that build if it's got a critical vulnerability that has a fix available. Once that is past that process, then typically the build process would put it in this registry here, maybe a pre-production or production registry. And here you also want to continuously scan the images in your registry. When you do that, you will see a layered view of all the vulnerabilities in this image. So in this case, there are 5 critical ones. For medium, you can see the run command that was used to build this layer of the image. So it makes it easier to get back to the dev team. We're also going to provide a list of modules. This is great if you are moving toward an SBOM approach to build a component or module list, inventory list of everything in your images. And you can get this through a CSV download. You can use the REST API to pull these as well.
Does that work with build packs as well?
I'm not sure if it does. Probably need to get back to you on that. And then we will also run a bunch of compliance checks. So anything that's related to image compliance checks, Docker, CIS benchmarks, as well as looking for various secrets, potential secrets. I don't see any called out here, but we have built in a bunch of different secret detections like AWS keys or even social media keys. If we detect that in the image, we'll alert you to compliance violations. Now, the reason, here's the system components, by the way, the NeuVector components. The reason, one good reason for admission control is to then, or for registry scanning, is to then link that to admission control. So if you're not familiar with admission control, you can specify a number of different rules to allow or block deployments into the environment. So here's where we're going to hook into the API server, the webhook, admission control webhook. And again, you can put this in monitor mode where we just alert you, but allow that deployment, or protect mode, which is going to block anything that meets these criteria. So specific CVE names or critical ones that have fixes reported 7 days ago, there's a number of flexible rules that can be created. We even have one which is a PSP equivalent. So many of you know their PSP is deprecated, going to be removed in 125. So this is some of the most core things that we feel are in PSP: privileged root, sharing host PID namespaces, etc., privilege escalation. And then we also recommend you add other criteria like scoping this to namespace to kind of customize your PSP policy here. This is really just an example, but you can craft your own custom rule comprised of many different criteria. You could see here, environment variables, image compliance violations, only allow from trusted registries, don't allow certain mount volumes, or only allow certain mount volumes, require resource limits to be in your deployment. So there's a number of different criteria you can use as your final gate to prevent unauthorized deployments. And as I mentioned, 5.0 brings CRD to be able to automate the creation. In fact, this rule right here was created by a CRD. So like most of these rules, I can select and I can edit. If they're, see, I can have that edit button, but CRD rules, that edit button will not show up because it must be updated by a CRD. The same would be true of federated rules as well. If they're pushed down from a federation central server, a local admin cannot go in here and change that through here. Need to go to the federated admin view to be able to change that. Now, if you're worried about, or if you want to build it into your process to evaluate your deployment YAMLs against policy, you can upload a YAML file here and we'll tell you if that is going to pass, if that's going to pass any of the checks below. Any questions so far, Robert?
We have one. I've been answering some of the ones I know about it. One of them was, does it run on Sysda Enterprise Linux? And I kind of finished that one already. But does NeuVector 5.0 require the latest Rancher 2.6.5, or could it be on a previous version of Rancher?
That's a great question. If you want this deploy through Rancher charts, single sign-on enabled, and it's going to pull from a mirrored Rancher registry, you need to use Rancher 2.6.5 or later. However, you can, if you had a previous version of Rancher, there was something called a partner chart that uses an older version of our Helm chart. So you can update that to the 5.0 version, and then you could deploy into older Rancher clusters. And of course, you can just use kubectl commands and sample YAML files or Helm directly on a Kubernetes cluster to deploy NeuVector on that. It does, it doesn't require 2.6.5. In order to do single sign-on, it requires 2.6.5.
I actually have a question. How do you, if we have an air-gapped environment that's not always connected to the internet,
Sure.
Is it NeuVector being installed to that environment, or can we manage that from like a centralized NeuVector when it comes online and I'm able to talk to it, I can scan and do everything, and it falls off, it falls back on. What's the recommended architecture for something like that? And the reason I ask is that the community loves doing things at the edge. So things on K3S that are air gapped are some of the questions that we normally get. So I figured I'd get ahead of it and ask.
Yes, I'm glad you brought that up. So we deploy in many air-gapped environments. We have many government customers and financial services where they're air-gapped environments. So in an air-gapped environment, you will figure out how to get a container image into that environment. And once it's in your local registry in your air-gapped environment, you could use any of the kubectl commands. If your rancher manager is running in your air-gapped environment, then you will have no problems deploying NeuVector. But of course, you've got to figure out how to get the NeuVector container images into that environment. The only potential issue is that as you see here, there's a CVE database with all the known CVEs at that time, and that is updated daily by NeuVector. So because CVEs come out, you could see here this was created May 21st, and I'm wondering if I haven't updated it since then, or maybe there hasn't been an update since then. But this gets updated regularly on the NeuVector public Docker Hub repo or the Rancher Mirror repo. So if your air-gapped environment does not allow to dynamically pull a new scanner image every day and check for it and pull it and reinstitute it, your CVE database will be behind. But you probably have your own processes for pulling images into that environment. So you would simply go through that process, whether it's a manual process, you want to update the CVE database once a week, or whether it's an automated script that you use to pull the images into, kind of a pre-staging environment outside your air-gapped environment, do your tests on it, qualifications on it, before you then are allowed to pull it into your air-gapped environment. Once the cron job runs, it'll restart the scanner. If there's a new scanner available, it will then update, of course, the new CVE database.
Awesome.
Yeah, and so in the Rancher 265 release notes and some of the docs, it says NeuVector is not supported in air-gapped environments. That's not quite true. It is supported. It's just you've got to figure out how to get the scanner and update it using your own methods for doing that. Good question.
Is the CVE database an image? The CVE
it's built into the scanner image.
Okay.
So the scanner container is updated as often as daily. And in it, when it's updated and pushed, it will have the latest CVE database in it.
All right. I'll put that in chat as well. I always like to kind of write it back. So there's obviously two versions. I think we have a slide that actually goes from the open source, because the open source and what's available for the open source free version and the paid version. Care to talk about that?
Sure. Let's see. I can go back to this. Let's see. So with, and the source code is on our GitHub/NeuVector, and then the images are on the NeuVector org in Docker Hub public. They're also mirrored in Rancher. So everybody gets all of the product features that we're showing and talking about. And of course, as you know, you can subscribe to SUSE standard and premium support plans. The one thing we wanted to call out, besides what you might expect from standard support, are these three things that you get from the support team. there's a lot of questions that come up about vulnerabilities, CVEs. Why is it showing up here? I just patched this. It's not showing up there. What is your feed? All of those types of things, working with customers to make sure they feel comfortable with the vulnerability scan results or how to interpret them and triage which ones are most critical. A lot of questions came up during Log4j. Which version of the CVE or scanner database is the latest that includes it? And we have to keep people updated as new CVEs for Log4j came out. Oh, you better update your scanner, make sure it's updated because there's a new CVE for Log4j. Best practices, hardening, we talked about segmentation rules, network rules, making sure that you have locked down your environment, whether it's from a network perspective or the process rules, or even just admission control rules. And then finally, getting access to all the most recent and latest protections that we can think of. When Log4j came out, within a couple days, we had a new WAF rule that you could deploy through a CRD or manually into the console, which would help to detect that exploit in process. So for example, if I look at WAF sensors, you could see Log4j. There's a WAF rule that came out immediately about how to detect this in progress. And the way these rules work, you apply them to any potential pods that may be taking ingress connections or vulnerable to this. And it's not a end all or catch all, right? Regular expression-based rules and WAF rules are not foolproof. They do need to be tuned to your environment, and hackers can occasionally find their ways around it. But again, I go back to the layered defense, right? Even if this wasn't detected at the ingress in the URL, there'd be a new process starting up, so NeuVector would detect it. There'd be an attempt to connect to an LDAP service that we would detect that, unauthorized connection, download of either vulnerable packages or command and control connections, those would be detected. So many different ways that Log4j could be detected and prevented, even before it was announced.
So community always likes to get some inside skinning or information. What is next, or what's some of the things that I know we just got out with the 5.0 release? Is there anything that you guys are looking at in the future, something that's next in the roadmap for NeuVector?
Yeah, I said at a high level, we're going to support the Open Zero Trust project integration. So KubeWarden is I would describe it as a customizable, flexible admission controller. You're required to write WebAssembly to program those rules, whereas in NeuVector, you get a nice GUI or REST API to create those. But if there's a specific policy you want to put in place or a specific thing you're transitioning from PSP deprecation, you can do it in KubeWarden. So, but integrating together with that, so you have more of a single console, and other Rancher products as well. And then on the vulnerability management and generally multi-cluster, we know that you're deploying not just one Kubernetes cluster, but 10, 50, 100 clusters. And there needs to be more tools to coordinate between those clusters. So for example, the CVE database, the CVE scan results, all of those things can and should be shared between multiple clusters. On the core runtime security, auditing the entire secure stack. So we talked about the entire SUSE security stack, being able to audit the entire stack for you, making sure if anything gets misconfigured, you're alerted to that. Edge is a big area of development because there's a lot of edge use cases, K3S deployments, Sleeve Micro deployments. So supporting containerized edge security is a big one. And then finally, more of a subscription service for customers to get the latest attack profiles and application protection templates, WAF rules, other things like that would be good for a subscription service as well.
Awesome. All right, so we have a question from Brian. Does NeuVector's Rancher integration understand Rancher-specific metadata for the purpose of marking up events, violations with Rancher cluster name and Rancher project name? Or does it only grok K8's namespaces?
I believe NeuVector is going to display things in Kubernetes terms and objects rather than Rancher projects. For example, when events are communicated in the event log, they're going to be, if there's a namespace in there, it's going to be the Kubernetes namespace. So for example, if we look at some of the events, network rule violation, you can see the kind of the namespace here. There are some special detections we do for Rancher, but that's really to determine things like, try to auto-determine the Rancher system containers and have special different protection profiles for those. And potentially in the future, like if we detect RKE2, we might be able to know that it's a container deployment, and so make configuration a little bit easier with that.
Awesome.
But we have some things for various orchestrators where, like if things are in the cattle system, we treat them differently.
We did have one person mention about the resources it uses from the CPU and memory load. I've personally installed this on my Harvester cluster, and I noticed it does use quite a bit of resources. But with everything that we're seeing that NeuVector is doing,
yeah,
I'm going to tell everybody we have to expect it, right? It doesn't come resource free. There's a lot of things that NeuVector is doing under the hood.
I would dispute you are using quite a bit of resources. If you're running on your laptop, then yes, I would agree.
So in the community, sorry, I should preface. In the community, small little computers, the Intel NUCs have been like our home lab devices of choice. We talk about that quite frequently because they're a step above Raspberry Pis. But
that would not be good for a NeuVector deployment. Probably not for a full-blown Kubernetes deployment as well. But as I mentioned, Edge, as we move to K3s and lightweight container or even ARM, we don't support ARM today, so ARM architectures. Of course, we'll need to tune NeuVector to be able to run in more lightweight environments. But in your traditional server environment, NeuVector, again, it depends on how you're running, how many nodes, how many workloads you're running. But we give a general requirement of, I believe it's 1 gig of RAM to allocate to the controller, the enforcer, and the manager. But if you're scanning huge images, then maybe the controller has to increase. Or if you're a financial services company doing very transaction heavy network connections, and you've got deep packet inspection turned on, then you may want to increase the CPU allocation to NeuVector or the memory.
Yeah, in the community, it's the small stuff that we get our hands on is usually like we had the same, I don't want to say issue, but the same limitation when Harvester came out, and we found the right workaround. But right now, when I got to touch it, and every time I talk to you, and I just tweeted this, I learned something more about NeuVector. So it's going down this path, but it does do a lot, and just seeing the power of what NeuVector's offering to not only security, but to the open source community is amazing.
Yep. Other questions?
I don't believe so. I think we talked about how to participate in NeuVector 5.0. We have obviously contact support. We have community through both the Registry Slack channel. It's linked here. Also with the NeuVector GitHub, you can post your questions there. I think we can wrap this up with some of the latest events that are coming. We have a hands-on rodeo that are coming, and I think our timing is a little bit off with the traffic K3S harvester build out. That was actually earlier today, so if you guys can catch that if you haven't caught it, if you didn't catch it, excuse me, you can catch that replay. You can head over to traffic, check that out. If you want to learn more about our events, it's www.susa.com/events. I think we can wrap. Oh, I forgot the Slack channel. You can always find us in the Ratchet Slack channel as well. I hang out there quite frequently, and in community.susa.com. So that being said, everybody, thank you very much, Glenn. Thank you for doing this once again.